Hi friends, welcome to my channel KK Physics World. We are going to learn about polarization by reflection. Reflection is simple way to produce plain polarized light. In 1808, MALUS discovered that when an ordinary light reflected reflected from the transparent medium like glass or water that light can be partially polarized. At incident angle, the reflected light has high degree of polarization. Thus, that angle is called angle of polarization. We call it as P. Just remember this. Okay. In 1811, Brewster's done a number of experiments to study the polarization by reflection at number of mediums. He concluded that at a particular incident angle, the reflected light has completely polarized in the incident plane. In 1811, Brewster's done number of experiments to study the polarization by reflection at number of mediums. At particular incident angle, the reflected light has completely polarized in the incident plane. So that angle is angle of polarization. P. We call it as P. Just remember this. Okay. From that conclusions, Brewster's proved that the tangent angle of polarization, we know the angle of polarization P. So the tangent angle of polarization is numerically equal to the refractive index of the medium. This is called Brewster's law. The tangent angle of polarization. So that means tan P is numerically equal to the refractive index of medium. Here mu is refractive index. Refractive index of the medium. Okay. He also discovered proved that reflected and refracted rays are perpendicular to each other. Okay. He also proved that reflected and refracted rays are perpendicular to each other. Okay. Now we see the proof. Angle between reflected and refracted rays. Angle between reflected and refracted rays. Okay. Now we draw a small diagram. Okay. Now we have to draw a small diagram. Okay. Suppose a beam of ordinary light incident on the glass plate surface at polarizing angle. We know the polarizing angle P. Okay. Previously we discussed that. Okay, just remember. Okay. The polarizing angle P is P for glass and air is 57 degrees. Okay. A part of light reflected and some part is refracted to the glass plate. Refracted to the glass plate. Okay. Now we draw a diagram. Suppose a beam of ordinary light. A beam of ordinary light incident on the glass plate. This is normal. Okay. When an ordinary light, we know the ordinary light, 3D light is called ordinary light. Do you want to learn about ordinary and polarized light? Please check my video. I leave the video in cards. Okay. When an ordinary light incident on glass plate, then it reflects this is polarized light symbol. We discussed this in previous class. If you don't know my previous class, please see my previous class and support me. Some angle is reflected and some angle is refracted. The polarizing angle P for glass and air. Glass and air is 57 degrees. Okay. This is 57 degrees. Okay. A part of light reflected. A part of light here is reflected and some part is refracted. Refracted means it's go down to the medium. Here angle is R, that is refracted angle is R. The angle between reflected and refracted is 90. We see this is perpendicular 90 degrees. We have to prove this. The refracted ray also a polarized ray. The refracted ray and reflected ray has 90 degrees angle. Okay. Here is incident angle P. This is also a P. We know that 57 degrees. We know that incident angle and reflected angles are equal to each other. Okay. This is unpolarized light. Unpolarized. This is polarized light. Polarized. Okay. So now we mathematically prove that refracted and reflected rays are perpendicular to each other. We know the Brewster's law. So from Brewster's law, we know the Brewster's law. Previously we discussed that Brewster's law. tangential angle is equal to the refractive index of the media. Okay, tangential angle is equal to the refractive index of the medium. Just we put it one from Snell's law. We know the Snell's law. The ratio between sine angles of reflected and refracted angles are, here is reflected angle P, here is refracted angle R, is equal to the refractive index of the medium mu. Here 2, from 1 and 2 we conclude that 1 and 2 we conclude that sin P by, here sin P by sin R equal to tan P. Tan P can write as sin P cos P. We get cancelled sin and sin. So we have here sin P and sin P cancel. So we have sin R equal to cos P. Okay. When we have to change cos angle into sin angle, then we put sin here and 90 minus theta, that means P. Here is sin R. Sin will get cancelled and R equal to 90 minus P, that equal to R plus P equal to 90. That is, R is refracted angle. R is refracted angle. Here P is reflected angle. Here P is reflected angle. So these are perpendicular to each other. That means it has 90 degrees between the angles of reflected and refracted. We have to conclude that the angle between reflected and refracted rays are perpendicular to each other. Okay, do you want to know about polarization? Please watch my video. I'll give you the video in cards. Okay friends, please subscribe my channel and share my videos to your friends. Please support me. Thank you.